Guys, we're going to learn how to do 6.1 today. This is going to be our sine arrays. Let me share my screen. Okay, so I'm going to go through this problem on example 1 to kind of remind you about what a sine array is. We did this a little bit before, but we haven't done it very much. So kind of a fast way to determine where the graph is positive or negative. Okay, so the first thing I have to do is make sure that there's not a -1 on the first x squared or the first term. If there is a -1, I'm going to add an extra row of negatives. Okay, so if a -1 is there, then add an extra row of negatives. And I'm going to go over that a little bit more as I write out this sign chart. Okay, so the second step, I need to factor. So I can look at this. I don't know where this equals 0. So I need to factor this to find out where that equals 0. So to do that, I do my chart, -24 to add up to 2. And that is 6 minus 4 gives us our 2. This is going to be x plus 6 and x minus 4 is greater than 0. Okay, so we factored that. That will give us our two values where the graph will change from positive to negative. So I'm going to set this parenthesis, which is x plus 6 equal to 0, and I get -6, and x minus 4 equal to 0, and I get a 4. Now, each of these have a multiplicity. If you remember, the multiplicity is the power of each binomial. Since there isn't a power here, it's automatically a 1, so I don't have to worry about repeated zeros on this problem. Okay, so I'm going to write this out to the side. So there's no repeated zeros, and there was not a -1. So the reason why I wrote those two things down is because if we turn this page over, right here it says there's 2 exceptions when using the patterns in sine arrays. The first one is if you have a -1, okay? And the second one is if there's multiple zeros. So these are our 2 cases that we have to watch out for. And if that first term is a negative, then we would have to do an extra row of negatives, okay? This is asking you to divide everything by a -1, which would make you change the sign at the end. I think it's easier to just add a -1 right here. Add an entire row of negatives. Okay. All right. And then in the multiple zeros, so if I have a multiplicity of 2 or even a multiplicity of 6, that means I would have 2 zeros at 3 or 6 zeros at -7. Okay. So if you have an even number of multiplicity, you would do 2 of that sign. So -3, I'm going to repeat my row, so twice. And then on this one, on B, if I have a 5, then I'm going to do only 1 row. Okay. If that's hard for you to remember, you can always do this same number. If it has a 2, I can do 2 rows. If it has a 6, I can do 6 rows. But 2 rows would be enough for any even number. This has a 5, this has a 9. I could do 5 rows, but 1 row would be enough because a negative times a negative times a negative is still negative. And so it doesn't matter how many of those negatives I have, it's going to be the odd number. And it kind of gives you an example down here a little bit lower. So -3 on this problem, I'll just write it right here, is repeated twice. It has a multiplicity of 2. So for -3, I have a row of negative, positive, positive, and then I do the same thing, negative, positive, positive. So these 2 rows are just for the -3, okay? And then the 4 only has 1, so I would only do 1 row, and then that's how I could figure out my sign. Okay, so that's just a little side note of a couple of exceptions. So now that I have my two numbers, -6 and 4, I'm going to make a sign chart. Now I want to notice if this is a greater than or less than. So this is greater than, so I'm going to look for positives, okay, because it's greater than. And then it's not equal to. So the easiest way to show not equal to is going to be to do a parenthesis at -6 and a parenthesis at 4. Now, sometimes what I'll do is instead of doing a parenthesis, I would do a dotted line here and a dotted line here because they're not equal to. Okay, and you'll see where that will come in common in a minute. Okay, so I'm going to do my sign chart, and we've done this before, but I'm going to do it again. So we're going to say, let's say that this number, -6, that this is my line, y equals, or my line for 0, okay? On the left side of 0, we get a negative number. Anytime I'm on the left side of 0, it's always negative, and the right side is always positive. So this is going to be positive, and that's going to be positive, okay? So this is my first row for x equals -6. Okay, now, if I scoot over and I say that this is now 0, now I have to do another row. So this is going to be negative, negative, and then positive. This is for x equals 4. Okay, so I make my rows. Now I have to multiply these together. So a negative times a negative would give me a positive. So anything in this interval is positive, okay? And then a positive times a negative is negative. Positive times a positive is positive. So my final answer is positive, negative, positive. Okay, so using this sign chart, I'm going to look. I want positives. I already wrote that down. So my answer is going to be these positive numbers. So my interval on my number line, -infinity to -6. Those are positives. And then 4 to infinity. Those are positives. So our answer is going to be -infinity to -6, parentheses. Can't see that. Okay. And also from 4 to infinity. That is where this graph is positive or above the x-axis. Okay. Now, is it possible to look at my calculator and plug this in? So x squared plus 2x minus 24. And then I graph. So I notice that it's above the x-axis here and above the x-axis here. So I would have to find these 2 points if I didn't already factor it and know that this was -6 and +4. Because even though it looks like 1, 2, 3, 4, 5, 6, I don't know that that's exactly it. It could be -6.00001. And if you put -6, you would miss it. So you want to make sure you know what those exact numbers are. I'm going to show you one other thing you can look at, but I'm going to caution you a little bit on doing this. When you do it this way, it will not tell you if it's a closed or open circle. And if there's a space where you have to stop, it won't stop. It's a continuous line. So if I push second math at the end of my problem, it'll let me put in the inequality, okay? This one is greater than 0. So I put greater than 0 and I graph. So what my calculator is going to do is it's going to draw the values just like we would on a number line. So it's going to go -infinity to this where it stops. Now, again, I have no idea that that's -6 if I didn't factor that and know that that number is -6. -infinity to -6. That does not tell me if it's an open or a closed circle. I would have to know that that's a parenthesis, okay? Over here, 1, 2, 3, 4, I could take a good guess that it's 4, but I don't know for sure. 4 to infinity, okay? That's a couple of ways that you can check your answer to see if it makes sense. Now, remember, you have to show your work to get any points, but it's always good to double check your answers to make sure that you are following the right way. All right, so we've got a couple more examples like this. So I've got 2x plus 1 equals 0 and 3x minus 2 equals 0. Okay, so we're going to subtract the 1, divide by 2, x equals negative 1/2. Add the 2, divide by 3, x equals 2/3. Okay, so I know my two numbers. First of all, this has a multiplicity of 2, so I have to do 2 rows. This one has a multiplicity of 3, so I'm okay just doing 1 row. Okay, so I can write this down here to help you remember. 2 rows and 1 row. Okay, so let's do our number line. So I've got a negative 1/2 and a positive 2/3. This again, looking at this sign, is less than. So I want negatives and it's parentheses. Okay, so again, you can do an open circle like this, or you can do a dashed line so that you know it's not a closed circle. It's not included. Okay, this is negative infinity. This is positive infinity. So I'm looking at these intervals from here to here, from here to here, and from here to here. I'm going to do it one at a time. So if I look at this line, negative 1/2, this has 2 rows. If I look right here, 2 rows. So it's going to go negative, positive, positive, and then I have to repeat that row again. Negative, positive, positive. Okay, so those 2 rows are for the negative 1/2. Then I go to the 2/3. This has a multiplicity of 3, which is an odd number. So I just need 1 row. So when I do my 2/3, I'm going to put my pencil here. On the left side of my pencil is negative, negative, and then positive. Okay. Our other exception, remember, is if we have a negative. So if I look right here in the very front, I don't have a negative, so I don't have to worry about that row. So now I'm going to go, what's a negative times a negative times a negative? So negative times a negative times a negative is negative. Okay, negative times positive is negative, positive. So this is going to be negative, negative, positive. But what you have to remember is that you've got this dashed line right here. So you have to stop right there. You can't just say negative infinity all the way to 2/3. I have to go negative infinity to negative 1/2 and then negative 1/2 to 2/3. When you do my little trick in the calculator, this second math thing, it's just going to draw the line. So we're going to know if you just use your calculator because you just went straight through it. Okay. So less than is going to be negative infinity to negative 1/2 parenthesis, negative 1/2 to 2/3, also parentheses. All right, let's check it. So I'm going to graph 2x plus 1 squared, and then 3x minus 2 cubed. Second math, this one is less than. Oops, I hit second wrong button. Second math, less than is number 5. Less than 0, graph. Okay, so when I look at this, it looks like it goes from negative infinity all the way to that point, which I would have no idea what that was if I didn't solve this, right? You would have to know exactly what that stopping point is. Luckily for us, we already do. We know it's 2/3. So it was negative infinity to 2/3, but I had to stop at negative 1/2. Okay, all right, let's do the next one. So x minus 2 equals 0, and we get 2. Now I know that this is a square root, and square roots have to be greater than or equal to 0. So x has to be greater than -3. So even if it says it would work on the left side of -3, I'm not going to include it, okay? I don't have any repeated zeros. I don't have a negative, so I'm just going to do my same old chart, -3 and 2. Okay, we're going to make our chart just like normal. Negative, positive, positive, negative, negative, positive. Okay, now remember, anything on the left side of -3 isn't going to matter. So let's cross this off so we don't even look at it, okay? Because I can't use anything because of that square root restriction, that domain restriction right there. So this is going to be positive divided by negative is negative, not divided. Positive multiplied by negative is negative, and then this is positive. So we've got a negative here and a positive here. So the only time this is going to be positive is from 2 to infinity. Now, I didn't mark if 2 was an open or a closed circle, so I'm going to have to know exactly what I'm doing to go back to this. There is an equal to here. Okay, I'm going to circle this. So first of all, we want positives because it's greater than. And then it is equal to. So it's a closed circle here. So if I were doing this, I would do a straight line that's included. It's not a dotted line. So the positives are going to start at 2 as a bracket and go to infinity. Okay. This one, x minus 3 square root, x plus 3, and this is actually a 2. Okay, and then this is greater than or equal to, so second math, and this is number 4. Again, that's not going to matter because it won't show you that greater than or equal to. What did I do wrong? Oh, I included it in the root. Okay, let's delete that out of the root and then do it. I'm glad I could do this so you guys can see what types of things can happen. Okay, now that looks better. So see how my greater than is not underneath the root. And then hit graph, and it will show me from here to infinity. So 2 to infinity, and it didn't have anywhere to stop, but I need to check. Okay, all right, we have 2 more examples, and these ones are rational. Okay, so there's one extra thing with rational is you need to find your vertical asymptotes. So remember, set the bottom equal to 0. Okay, basically I'm finding my excluded values. So this is x minus 4 and x plus 4, because that's a difference of squares. So the vertical asymptotes are 4 and -4. And then if I set the top equal to 0, I just get 3. I have 3 places I have to write on the number line. Negative infinity to positive infinity. I've got -4. Now, even though this is an equal sign, the asymptotes will never be included. Okay, so the asymptotes will never be included. So at -4, I'm going to have an open circle. It has to be a dashed line. Okay, and at +4, I'm going to have an open circle, and that's a dashed line. So even though it has an equal to right here, you cannot include these asymptotes. Okay, and then 3 is going to be right here, and 3 is included. It's a solid line. Okay, so I've got dotted, solid, and dotted. Now, I don't have any repeated zeros, and I don't have a negative in front, so I'm just going to do my normal sign chart. So negative, positive, positive, positive. If I look right here, only one of those would be negative. And then if I shift over here, negative, negative, positive, positive. And if I shift over here, negative, 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 positive. So for my final answer, I get a negative here, a positive here, a negative here, and a positive here. Okay, it doesn't always alternate, so you do have to go through those steps to make sure. These ones want to know less than, so I'm looking at negatives. So my negatives are from here to here. So negative infinity to negative 4. This is a parenthesis. Okay. And then my other negative is here to here. This is a bracket. Okay. Let's check. Really important if you're using this calculator that you get your signs in the right place. Okay. So I'm going to do second math, less than or equal to 0, and graph. Okay. So we see from here to here, that's my negative infinity to negative 4. And then here is my 3 to 4. Okay. And I had to know 3 is a bracket. You got to get that bracket right on number 3. Okay. Now the last one looks kind of complicated, but I know the absolute value is always positive. Okay. So I don't have to take into consideration the absolute value. It's always positive. So the only thing I have to look at is the 5. And it is a bracket. It's equal to. And I want to know the negatives. Okay. So negative on this side, positive on this side. Negative infinity to positive infinity. And I've got negative infinity to 5. Now, I do have to keep in mind that there is a break right here. If x equaled -1, I would get 0. So x can't be -1. So we do have an asymptote right here at -1. Okay. And I don't have to, like, they're all going to be negative. I didn't have to do a chart for that, but I do have to stop at the asymptote. So when I'm doing negative for this, it's going to go negative infinity to -1, and then -1 to 5, and 5 is a bracket. So it will be negative basically for the whole graph until 5, but it is going to stop and just be an asymptote. Okay. So I've got divided by the absolute value of x plus 1. Second math, less than or equal to 0. Remember, I'm only doing this to check my answer. Okay. So you can see that this is going to cover the whole thing, negative infinity to 5. But if you didn't stop at the -1, you wouldn't get it right. And you need to know that's parenthesis and that's a bracket. I'm going to show you this graph actually, okay, so you can see what's happening here. So delete, delete. I'm just going to graph this like normal. So notice from here to here, this is our -1. It's below the x-axis. And then it still is below the x-axis up until 5, and then it crosses and goes above. So negative is here to here, and then here to here. Okay. All right. So that is going to be, so the majority of this is doing your sign charts and then checking your parentheses and brackets. And good luck on that. Let us know if you need help.